Welcome back with more example about naming alkene. And in this case, we have a structure that from any side that we reach to it, the double bond, it will be between the fourth and fifth carbon. So if I start labeling it from the left side, I get 1, 2, 3, 4, 5. This one will be 6, 7, 8. And on the second carbon, we have a substituent, and then on the fifth one and 7. But if we start labeling it from the right side, we get 1, 2, 3, 4, 5, 6, 7, 8, and that's going to give us 2 on the second carbon. We have the bromine and bromo group, and then we have the ethyl on the fourth one. Next one, it will be on the 7. Clearly, this is going to be the correct answer. Okay, this one will be the correct answer. So again, we have a bromo, ethyl, and methyl, and we label it from here: 1, 2, 3, 4, 5, 6, 7, 8. So the way you're going to name it, you're going to say on the second, I see bromine. And why bromine? Because of the B, if you alphabetize them. So 2 bromo, and then 4 ethyl, okay, because of the E. And then you say 7 methyl. And we have a double bond and it's sitting on the fourth carbon between the fourth and fifth one. So you say, after saying methyl, then you say dash, you say 4. Okay. And we have 8 carbons. So we say oct for 8 carbon, and we will add En to the end of the name. And another way to name this compound is to copy paste almost everything except this part of the molecule and the name. And when you said 2 bromo, 4 ethyl, 7 methyl, then you will say I have 8 carbons. Okay, this is the main chain or parent. I have 8 carbons, so I'm going to say oct, okay, for 8 carbons. And then I say dash for position of the double bond. And I want to say I have a double bond, I add ENE at the end of the name. And so that means the correct answer, it will be this. This is going to be the correct answer. A, it will be the correct answer. Very good. Next one. Next one, you can start labeling from here. Let's start with red. 1, 2, 3, okay, 4, 5. Okay, so on the third carbon, we have 2 methyl group. Okay, and next, I can start labeling it from here. 1, 2, I go counterclockwise. And that's going to give me 5 and 5. Okay, which one is going to be the correct? Clearly the 33, because it is giving you a smaller number. Okay, so let's get rid of the blue numbers. Okay, those are gone. Okay, now let's name this compound. The way I'm going to name it, it will be 3, okay, on the third carbon. Okay, I have a methyl, then I say comma. Why comma? Comma, you will use it for identical substituent. When you have 2 or more identical substituent, you will use comma. And then you say another 3. Okay, why another 3? Per each substituent. Per each substituent, you need to have 1 locator. You have 2 methyls. Per each methyl, you need to have 1 number to show position of that methyl. Okay, and we call them locator. Okay, 3 and 3, dash, di, methyl, di, methyl. So we had 2, and it's a di, and methyl, YL, to show that it's attached. Okay, we have a ring. So we're supposed to say cyclo. Okay, made of 5 carbons. And then we say pent for 5 carbons. And then I'm going to say ENE. Why I'm not saying position of the double bond? Okay, it's not hard to figure the position of the double bond. Wherever you have the substituent, go back by 3 carbons. And if I go back, starting from here, 1, and I go back, this is going to tell me where the double bond actually started. Okay, and that's the reason we don't show position of the double bond. Okay, by saying, like, you know, where exactly it's standing. Okay, how about here? In this case, you can say, let's start from there. 1, 2, okay, 2, 3, 4, 5, 6. That's one way. Okay, and what do we get here? We get 3 for chlorine, 4 for methyl, and 6 for bromine. So 346. But if you go counterclockwise, you get 1, 2, 3, 4, 5, 6. That's going to give you 3 for bromine, 5 for methyl, and 6 for chlorine. Again, which one is the correct answer? It will be that. Okay, that's going to be the correct answer. So I'm going to erase those numbers. And again, you need to prioritize them based, and how we do it, like alphabetize the substituent. And in this case, bromine will be the first one. So you will say 6 bromo. And then we get 3 chloro. Next, we get 4 methyl. Okay, get that one. And let me move this one a bit down. Okay. Maybe I need to rewrite it down. Okay, so I got 6 bromo. And then we said 3 chloro. Then 4 methyl. It's a ring, so we're going to say cyclo, made of 6 carbon. That will be hexene. Hexene. And that's going to be the correct name for it. Okay. Very good. I think we practiced enough about naming alkenes. Let's move on. Now, we have some common terms for alkenes that you will see them a lot. One of them is vinyl versus allyl. Okay. Whenever we say vinylic carbon is a carbon that has sp2 hybridization, okay, both sides there will be sp2 technically hybridization, and allylic you will have a carbon that attached to a double bond, okay, a carbon that attached to a double bond. That carbon we call it allylic carbon. Okay, let me present one example. So here we have R. R is going to be the alkyl group. So R is going to be the alkyl group. Okay, what does it mean? It means it can be anything. It can be CH3 that attached to something. Okay, and this one we call it alkyl or R group. Okay, okay, so this is going to be the R technically group. Okay, now area that I'm going to highlight those two we call them vinylic carbon. These two, they have sp2 hybridization, and name for those 2 carbon we call them vinylic carbons. Okay, vinylic carbon. And the neighbor 2 carbons that I showed them by star, those we call them allylic carbon. And what's the difference between vinylic and allylic carbon? And that's going to be the hybridization. Okay, for allylic carbon, the hybridization, it will be sp3. Okay, while vinylic, it will be sp2. Again, allylic, it will be sp3. So you have sp3 here, and there sp3, while these 2 are sp2. Okay, now let's go more. We said we have a double bond. We have 2 carbons attached to each other, and there is a double bond between them. This one we call it vinyl. Okay, vinyl. And if you take one of the hydrogen, okay, any hydrogen, say for example this hydrogen, take that hydrogen and replace it by a group, anything. Okay, so I'm going to replace it by a group, and I'm going to attach this one to something else. Okay, whatever. Okay, this part of the molecule, we're going to call it, okay, we're going to call this part of the molecule from now, we will call it vinyl group. Okay, So that's going to be vinyl group and is attached to something. And what's that something? It can be X, whatever, okay? Whatever. The one I'm talking about, it will be entire of this piece. Okay, entire of this piece, we call it vinyl. Vinyl group. So vinyl group, it has 2 carbon and 3 hydrogens. Okay. We said this carbon, we call it allyl. Okay, allylic carbon. Okay, and if you take one of the hydrogen and replace it by any group, let's say I have 2 here, then I'm going to attach this one to something and X whatever. Okay. This part of the molecule, from now, we're going to call it allyl. Okay, so this one, we're going to call it allyl. Okay, allyl is attached to something. Vinyl attached to something, and you can have anything attached to it. So X can be anything. Okay, why do we care about, the allylic carbon? Okay, reason for it, if you remove one hydrogen from a carbon that it has sp3 hybridization, this carbon, if you remove one hydrogen from it, and let's say you remove it as a H plus, or you remove it with, like with 2 electrons, you might get -1 charge, okay, and that carbon, and this one, it can go through resonance, and it will do this. Okay, double bond, the lone pair will move there, and those 2 electrons, they will move to this carbon. Okay, so what do we get? We get carbon with 2 hydrogens, and it will have lone pair, and then carbon here, we get double bond there, and this carbon is going to have 2 hydrogens attached to it. Okay, and of course here we have 1 hydrogen there. Okay, so highlight this carbon. Okay, now that carbon, it has 0 formal charge, well, used to be minus, and the yellow carbon, that carbon, now it has -1 charge, which used to be 0. So we got resonance structure. We can get resonance structure with a positive charge as well, but in this case, those 2 electrons, they go opposite of the top structure. Those 2 electrons, they go here. Okay, they go here, and they leave carbon, the yellow carbon, with a positive charge, and the orange one, it will be involved in a double bond. Okay, so we get this structure. We get carbon attached to another carbon, double bond here. Those 2 carbon, that carbon is going to have 2 hydrogens, and here we have 2 hydrogens, and we left this carbon with a positive charge, and that's okay. That's a yellow carbon. So again, we got resonance structure, and that's the reason the structure, it will be stable. Okay, why we do care about allylic carbon? Because they will affect the speed of the reaction, and you will see it whenever we're talking about chemical reaction. We say that carbon, it will be favored. Why favored? Because of resonance structures. Okay, now in organic chemistry, we have a common names for them. As you see, we have a vinyl group, allyl group, or methylene, and also methylene versus chloromethane. Okay, don't be surprised if you see chemists are using different name for those compounds, because for one organic compound, frankly, you can easily come with 2 or at least 3 names. Okay, and I'm gonna practice some of them for you. Okay, let's start with this, like a basic molecule. Here we have a methyl, okay, attached to a ring that it has 6 carbon. So that's going to be the parent. Okay, so I'm going to say I have a group that is methyl. Okay, I'm adding YL to say this is attached to cyclohexane. Okay, I'm adding AN at the end of the name to show that it's saturated. Okay. How do you want to say that chloride attached to methyl and methyl attached to ring? Okay, again, your ring has 6 carbon, so that's going to be the parent, and is cyclohexane. Okay, I want to say this verbally. I want to say this. I have a chloride attached to methyl, and the methyl attached to the ring. So I say chloro, that means I have a chlor, okay? Chloro, I have a chlor. Where is it? It's attached to methyl, attached to, okay, one carbon. I have a chloride attached to one carbon, okay, one carbon and one carbon. Next, this carbon plus the chloride, both of them, okay, both of them are attached to the ring. In order to say attached to the ring, you add YL. So I want to say entire of this piece attached to the ring. Attached to the ring. And how do I say it? I say chloromethyl, okay, chloromethyl, and then I say cyclohexane. Okay, cyclohexane. Okay, next one. I have a methyl that's attached to the ring, but our methyl, it has a double bond. Okay, so it's involved in double bond. Again, okay, compare number one with the third one. We want to say we have a methyl group. We have one carbon. METH represent one carbon. Okay, this piece is attached to the ring. How do you say it? YL. Okay, so until now, we say we have a methyl, CH3 attached to the ring. Clearly, it's not CH3. I want to say it has a double bond. So what do? I add EN here. Okay. And then what else? And then I say cyclo. Go. Hexane. Okay, hexane. Okay, cyclohexane. Okay, check again. Okay. And so we got methylene group that is attached to the cyclohexane. Okay, how about this? This one, okay, we have two carbons that they are involved in a double bond. Okay, and this one is attached to the ring. So you can name it vinyl, because this is a vinyl group. So you say I have vinyl. Okay, vinyl cyclohexane. Okay, or how about this? Why don't you start labeling it and start labeling it from the first carbon, okay, wherever you have the double bond, and also you have the substituent. So you can say on the first carbon, I have cyclohexane. Okay, I have cyclohexane. Okay, have cyclohexane, and then I can say one, okay, one, and then I say one here. You can say one, and then say ethene. Okay. Frankly, we don't use this one a lot, and so I prefer not really to mention it. I should say cyclohexyl. My bad. Cyclohexyl. I'm sorry about it. Cyclohexyl, because we want to say is attached to the ring. It's not that common. Okay, this one is actually the top one is more common. Okay, so it will be cyclohexyl 1 and then dash ethene. Okay, next one. What do I have? I have 3 carbons. From the allylic position is attached to the ring. So I'm going to say, how about this? I have allyl. Okay, allyl. So I say allyl cyclohexane. Okay, or you can say this 1, 2, 3. Okay, so on the third carbon we have cyclohexyl, and then okay, then you will say I have a double bond. Where is it? On the first carbon. And then I say I have 3 carbons technically, so it will be propene. That's another way to name it.